In this video, we're going to take a look at what's called an arithmetic series. Make sure that you edit the number in the corner to be the number that matches with our notes, not that number 4. So the definition is the terms of an arithmetic sequence added together. For example, a finite series, we could do 2 plus 4 plus 6 plus 8, and then stop. Finite means it ends, as opposed to infinite, where it would keep going. We usually show that it keeps going with a dot, 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 and it means it would continue. Now we're bringing back the runner example we did on our first day when we did the arithmetic sequence, in terms of finding the total distance that the girl runs by the 10th week. So we have our first week, she ran 5 miles. Each week she ran 1.5 miles more. And then in the last week, the 10th week, she ran 8.5 miles in that week. We need all of that information to help us with deriving a formula for this. You already did the following, where you wrote out 5 plus 6.5 plus 8 plus 9.5 plus 11, 12.5, 14, 15.5, 17, and 18.5. And you went to your calculator, added everything up. I'm going to try a different approach here. We're now going to look at the first and last number and add those together on our next line. I'm going to let you do this, and then you're going to do one in, so 6.5 and 17. And you're going to keep going one to the right and one to the left each time you're adding. I'm going to run out of colors, so I'll do the next one in green, 8 and 15.5, 9.5 and 14. And the last are the two that are left in the middle, the 11 and the 12.5. So take a minute and add up each of those sets of numbers and see what you get. You should get 23.5 for each of them. The same number. And that's a key number because since they're all the same, we can use that to develop a formula just using the first two numbers, which we have formulas already to calculate. We should already know the first term, and we have a way of calculating the last term. And then, right here, we have 5 sums that we got from 10 total numbers, which is half of our total number of weeks we're looking at. So let's fill in what we know. If we do 5 times 23.5, that gives us the actual sum that we're looking for. But let's rewrite that. 5 comes because it's half of 10. 10 is a number we know. Times the sum of what I circled, 5 plus 18.5. If we replace that with the fact that we know in this case n is equal to 10 and we know all of this other stuff here, I can make this formula into n over 2 times a1, because that's my first term, plus an. And an will change depending on what our n value is. In this case, our n value is 10. And then 18.5 was really our a10. So that an will change depending on the formula. And we have that formula written down below for you also on this page. So let's just try 2 examples using this formula to wrap up this video, and then we'll do some more examples in our second video. if we need it. We might not need the second video for that. Take that back. All right, so let's find each sum. We're given A1 is 4, A16 is 44. We don't know S16, so that's what we're finding. But because really this is our AN, we do know that N is equal to 16. That's going to be important to plug that in later. Something we're always going to have you do initially with all this stuff is write the formula out first before plugging in the information we know. So we're doing S16 equals. We know that N is 16. We know that A1 is 4. And AN is A16. They're the same thing. So we're going to do plus 44. You should be able to, just like we did with arithmetic, plug that straight into your calculator. So let's do that right now. I chose not to use the fraction tool here. You definitely can. And then we get a sum of 384 for this one. Our second one's going, at third one, will take a little bit more work because we don't know AN. We do know that N is 11, but we need AN or A11. That's a question mark right now. So we need to go back and use our formula for our arithmetic sequence. A1 plus D times N minus 1. Fill in what you know. So 15 plus negative 2, or just minus 2, times 11 minus 1. And then we can plug that in our calculator all in one shot. And we get negative 5 for A11. This is our AN that we can use to fill into our next formula. N over 2 times A1 plus AN. We know that N is 11, so 11 over 2. We know A1 is 15, and we know that A11, or our AN, is negative 5 because we just solved for that. So now we, again, can go back to the calculator to find our sum, which is 55. Did not mean to switch that over so quickly. If at any point this goes too fast and you need to pause it, go for it, or rewind a little to make sure you get the stuff copied, please do that. And now our last example, we almost have the same information, we just have to find it from our sequence. So we have our first term is 25, and then what are we adding each time? Well, we're adding 25 each time to get to our next term, so that's also our common difference. We don't know how many terms we have, but we do know that 250 is our AN right now. So let's use that formula to solve. So I'll put in 25 plus 25 times N minus 1. And I notice I'm missing N and AN, but I just told you that AN is 250 because that's our last term. So let's plug that in and distribute so that we can finish solving for N. So these cancel. We can then divide by 25. So we will get that N is equal to 10. And now we'll have enough to plug into our SN formula. I'm just going to highlight that this is N equals 10 here, so squish it in a little bit. So again, we're rewriting the formula. We now know that Sn is really S10 because we came up with our N value. So we'll put 10 over 2 in. We have that A1 is 25, that's our first term, and our last term is 250. And then same thing, let's go right to the calculator and plug that in. And we get a sum for S10 of 1375. So now that you've had a chance to see some examples done, a couple different types, you are now ready to start your practice. Make sure as you're doing practice or after you do the notes to ask any questions that you have about the examples that you've completed.